Today we're going to take a look at rotations. So in a rotation, the original object and its image are always congruent. And congruent means the same size and same shape. So clones of one another. But objects that are rotated around a fixed point, and that's called the center point. And there's two different ways an object can be rotated. It can be rotated clockwise, and if it is, it's considered a positive rotation. So that's positive rotations, and counterclockwise rotations are negative. So if it's rotated in this direction, it's considered negative. So let's just take a look at what I mean by a rotation. Let's say in this example we've got a little bit of an object, and maybe it looks like this triangle, and we'll call that triangle ABC. So this vertex is A, this vertex is B, and this vertex is C. And this is the original object. And then I want to turn this around maybe a center point down here. And I want to turn it clockwise, so in a positive direction, maybe 90 degrees. So it does get a little tricky to do this. I'm just going to imagine where this is. So here's like an arm extending out from the center point to A. That arm has to turn 90 degrees. So it'll be over here somewhere, and it'll be the same length. And that point there will be A prime. And then if I drew a different arm to B, and originally the arm was here, that arm's going to turn 90 degrees, and so it's going to be up here somewhere, B prime. And again, I'm just sketching this, so it's not a perfect way of doing this, but there's C, and I turn that 90 degrees, and so C ends up with the exact same length, maybe over here as C prime, and then just connect the dots. So there's A, B, and C, and hopefully those objects are congruent. They're exactly the same size and shape, and mine are a little bit off because I was just sketching this. But that's the idea of a rotation. Generally, the rotations that we do will be 90 degrees or 270 or 180 or 360 degrees around a center point. So they're not too bad, but you can do this with any amount of degrees, and maybe you need to grab a protractor to actually measure an angle and a ruler to measure those distances. It's possible to do this in a much quicker way if we do it on a coordinate plane. So if we're using a Cartesian plane, it becomes a lot quicker. So let's take a look at that with this next example. So in this example, we're going to rotate ABC, the triangle ABC, and let's rotate it clockwise 90 degrees. So to do this, what I want to do is give you some coordinates for A, B, and C, and those will be, well, A will be maybe 1, 2, so 1, 2, there's A, and B can be 5, 3, 1, 2, 3, 4, 5, and 3, there's B, and C, how about 2, 5 for C, 2, and 1, 2, 3, 4, 5 for C. So this was A, and B, and C, and we just connect the dots here, so there's our triangle. And I'm going to show you a different method so you don't have to grab a ruler and a protractor to be able to do these. The center point's going to be 0, 0, and I didn't put that in, but let's add that about the point 0, 0. That means this is the center point, also known as the point of rotation. So let's see if we can do this using a neat little trick. So this point here is 1 and then 2, and I draw a little arm, just like my own arm, just like a little stickman arm here, and I find it easiest to rotate that little arm. So if I were to rotate that arm around this center point 0, 0, clockwise 90 degrees, the arm would rotate this direction. And what the arm would end up looking like is it would be down this way instead, so that would rotate, and then it would be across here. So it's like 1 unit, turn, 2 units, 1 unit, turn, 2 units. The whole thing has rotated 90 degrees, and that's where the new point is going to be. And that new point I'm going to call A prime. And then I do the same thing, but I go and do point B. So B is across 5 and up 3, and then I turn that arm. So now it goes down to 3, 4, 5, and across 3, and that's where point B will be, and I'll call that one B prime. And I know that A and B were connected, so A prime and B prime are also connected. And then we do that for point C. So 2, 5, this arm turns and goes to 5. And I get point C prime, and I know that A and C are connected and B and C are connected. And then I just erase, maybe I used a pencil to get those ones. You don't have to, you can just maybe think about it in your head. I'll just erase those lines, and I have my image A prime, B prime, and C prime. And the points, so A, which was at 1, 2, has now moved to A prime, and A prime is at 2, negative 1. So you can actually locate where these points have moved to. 5, 3 has now moved. It's now 3, negative 5. So it's a new point called B prime, and it's at 3, negative 5. And this idea of taking these points and moving them to their prime locations, C is at 5, negative 2 now. This is called a mapping, and it becomes really useful when you get more complicated things to think about how objects, how points are being moved around by mapping where they are. And we'll see these sorts of transformations throughout math in high school again and again and again. So basically step 1 is map each point to its image, and then step 2, I just connected the dots that were corresponding, and I have all the new image from the original one. Let's just take a look at one more example of a question that could get asked this year. This is a bit of a working backwards one. So if I start with an image and an object, and its image is shown on the right, and my question is, where is the center of the rotation? And this is a bit tricky. You can see that this object has been rotated over to the right hand side, but it is quite difficult to figure out where that center of rotation is just by guessing. Maybe down here somewhere, maybe up here. It's kind of hard to tell. So there is a step-by-step process that you can go through, and you'll need a ruler, and basically that's it to be able to do this one, though it does take a couple steps. So the first step is to find two corresponding parts on the two different objects. If you've done that, then create a perpendicular bisector. Now that sounds complicated, but it's not too difficult. So perpendicular means meets at 90 degrees, and bisector cuts in half. So let's create. So first of all, I need to figure out how far it is from here to here. So you just use a ruler, then you cut that in half. So now it's bisected, and then the perpendicular to the bisector is 90 degrees to that middle point. So what we want is we want to draw in this line here, this green line. And you can do this from any 2 points at all. In fact, you have to do this again. And when you do this again, choose different points. So maybe choose the top of the house, and then connect the dots. Find the perpendicular bisector. So the middle point between those two might be here, and you go like this and create a perpendicular bisector. Now, I have not done this with a ruler, so I'm just estimating where the middle might be. And it should work for 2 points. If you find that it's not working for 2 points, do 2 more points. No matter which 2 points you end up picking, so you just have to make sure you get the corresponding ones. No matter which 2 points you end up picking, the perpendicular bisectors of all of those lines will all meet at 1 point. So I've actually repeated step 1 and 2 3 times. I did 1 and 2 in green, then I did it again in red, then I did it again in purple. All of those meet at that black dot, and that black point, that point of intersection, is the center of rotation. And you can kind of verify if I took that point and then the corresponding purple point is over here, that should be a 90-degree turn. And I actually used some software to take this image, clone it, and turn it 90 degrees onto its side. So it is correct. It looks like I've done a pretty good job with my estimations. So for this section, you're definitely going to need a ruler. Protractor could help if you have to turn something that isn't on a coordinate grid. You can always use the edges of a ruler meet at 90 degrees to get a good 90-degree turn as well. Okay, we'll see you in class for some practice.